Okay, so we're going to start off with uh, 6.1 graphical portion. So I actually already recorded this, but my dumbass deleted the file by accident. So, okay, let's start with this question. X. So let me kind of go through, uh, what is it? Some guidelines to the transformations, right? So let's say that I have this form, right? We're going to be seeing this form a lot. Now, this could be log or it could be ln x. I'm just going to use ln x for the sake of simplicity. Let me actually do this. So, there's a reason why I added this space in the bracket. I'll explain that later. There's something called stretching and compressions. Now, this is basically how the graph changes. There's also something called basically they're measured by scale factors. I'll explain that now. Anything that happens outside of this bracket is affected, like what affects y. Okay, anything that happens outside of this bracket affects y. Anything that happens inside of this bracket affects x, the x plane. These affect y, and this affects x, right? So let's say this was 2. Okay, so let's say this is 2 ln x, right? If there's 2 ln x, that means there is a scale factor stretch of 2. What is a stretch factor? I'll explain it here. So let's say a graph is like this, right? This maybe is 1, right? Now, let's see, this is 2. Let's take this and let's do it here. So they're basically the same thing. It's not completely the same. They're the same thing, but the difference is that they're this is 2 times more stretched than this one, right? Because this one's at 1, this one's at 2, right? 1 times 2 is 2. So I'm going to keep on using this because this is a pretty good example. So from here, you can write down this. Let's erase this part. So like I explained, it's a stretch factor of 2. That's when anything happens outside of the bracket. Now, what happens if something is inside of the bracket? Right? If something is inside the bracket, let's say you multiply it by 2, right? This portion, you would be compressing, right? With y we stretch and with x we compress. Now, what is a compression? A compression is just a stretch, the reciprocal of a stretch. So if this is 2x, that means that the stretch is 1 by 2. We have to use it in the stretch form. So, and the thing is, this graph is good because it also is an example of a compression. Let's say this point is 1, okay? And this point would be 0.5, right? 1 by 2, 0.5, right? This point would be 0.5. So, what would be happening here is that it's basically this, right? This is it. So it's basically just stretching. It's basically dividing the this point, the intersection point, by 2. So if this was 2, and let's say this intersects at 2, right? Maybe here, right? And the compression or the stretch is at 1 by 2. That means it would go here, right? So that's basically it. It's not a big, thing. Then from here, there's just one small thing. Let's say there was 2 here, right? X plus 2. That means we have to, from here, we have to follow a rule, okay? From here, whenever we have something like this in a bracket, we have to set this as 0. Now, you may ask why. There is a reason why we do this, but I'm not going to explain it because school fucking sucks and they can't explain anything. You're not going to need to know how to do this. But so from here we have to set this as 0, right? So from here this is equal to x minus 2. That means you're going to shift x by minus 2. So let's say this is at 1. That means we're going to shift it by minus 2. So we're going to put it all the way, this is 1, right? So then we're going to have to put it here. So minus 1. Right? So it would be like this. If this was plus 2, then we would, if this was minus 2, right? If this was minus 2, this was plus 2. Then this would be plus 2. So then you'd shift it more to like here, right? So, and then there's one last thing. One last rule. Let's say I have something like this, 2x plus 2. Right? If I have 2x plus 2, then the y stretch, like it's going to be 1 by 2, right? Or the x stretch is going to be 1 by 2. But the thing is, you also have to divide this by 2, right? There's a reason, but school doesn't really teach you it, so there's no reason to know it right now, at least. And you probably don't care enough to learn math. No one really likes math, but they just do it to pass exams. So this is just it's gonna equal to 1. You're gonna divide it by 2, so it's gonna equal to 1. So that means you're gonna, if you have 2x plus 2, what you're gonna do is you're gonna shift it by 1. So it'd be going here, and you're going to compress it by 2 as well. So first of all, you're gonna compress it, right? First of all, you're gonna compress it, so 1 by 2, and then you're gonna add 1. You're gonna subtract 1. So that's pretty much it. That's the guidelines. You may have, not understood that very well, but as I go on, you'll understand. So let's quickly do this, right? So 3ln x. This is happening outside the bracket, so we know that the y stretch. So y stretch is at scale factor. I'll do this. Scale factor of 3. Now b, let's go. B is y equals y equals ln x plus 3, right? So we're gonna have to describe that. So this is gonna be, we're gonna set this as 0, and then we're gonna move it to the other side, so it'd be x minus 3. So this is 0, so plus 3 equals 0, then x equals minus 3. So then this would be a transformation of minus 3, right? So this would be this. Minus 3, 0. Now what's this? What is this notation? This is the amount that x shifts, and this is the amount that y shifts. Y doesn't shift at all because there's nothing outside. There's nothing here, here. But here you actually wouldn't shift anything even if there was something here. But there is an x shift, right? So from this would be the answer. So you're not going to actually write these parts, you're just going to write this. For C is 3ln 2x. Now there is something acting inside of here and here at once, right? So it's a bit trickier, but it's the same thing. So y stretch is at this, it's at the scale factor of 3, right? And x stretch is at the scale factor 1 by 2, because you're going to find the reciprocal of this. So the compression is 2, but the scale factor of the stretch is going to be 1 by 2. Let's find d now. So d is 3 ln x plus 2. Now you may be like, okay, let's just do the same thing. Let's this is going to be the x shift of minus 2, right? And then this would be a y stretch by scale factor 3, but this is wrong because there's a sneaky thing here. It's not mentioning any brackets, right? So in actuality, it's this. And like I said, if there's something here, then something happens to the y shift. So this is a y stretch by scale factor of 3. This is what is it? There's not going to be any change for what is it? There's not going to be any change for x because there's nothing going on here. So then the next thing would be transformation, a shift of 0 and 2. So since this isn't in the bracket, you don't have to set this as like 0 or anything. So you just need to put this directly in. Right? So then E is equal to y equals minus 3 ln x plus 1. Right? So this would be a y stretch by a y stretch of write this down. Y stretch by scale factor minus, right? Y stretch scale factor of minus 3. Now, this I'll explain this more. Then from here I'll just write down the transformation minus 1 over 0. Right? Now, what this is you know how a normal logarithm graph looks like this, right? It doesn't look exactly like this, right? So you can see that x is increasing and y is increasing at the same time. Here you can see that x is increasing, right? But y is decreasing because, the scale factor, right? So how do we make it so? How do we draw a graph that looks like x is increasing, right? But y is decreasing? You would have to draw it. Say this is 1. You have to draw it like this. Right? So x is increasing, but y is slightly decreasing. Keeps on decreasing. Right? So this is how you draw the graph. I'm pretty sure the teachers explained that much, right? So now f y equals ln. Sometimes I think I don't think anyone's hearing me right now. I genuinely don't think so. I'm not sure if I'm doing this for a hobby or not. I think everyone just skips to these videos for like solutions. No one really like pays attention. Whatever. We can see something happen here, right? A bit of a different thing. Nothing happens to the y thing, so we don't need to worry anything about. We don't need to worry about y, right? But we can see that there is x compression. So the x compression or the x stretch is by scale factor 1 by 2, right? Now 1 by 2 this will equal to, and now let's see, it's 1 by 2, right? So now we're going to find the transformation here because we have a 4 here. So maybe you're tempted minus 4 and 0, but like I said before, that's not how you're going to do it. You're going to divide this by 2. So you're going to get 2 or minus 2. So this is the answer for that. Now, the next thing. Next question. So this is question 11. Right. I should probably. This may be a bit hard to understand without the graph, so I'm gonna quickly just drop the graphs here. So, okay, I don't think we need the graphs actually. I think I can explain this without the graphs, but let's do a reference graph, right? We'll keep something here. And I'm gonna draw this very carefully. We're gonna keep this here. We're gonna draw sorry, change to desktop. So we're gonna have this as 0, this is gonna be 1, and maybe this is like 2 or something. Right? So we're gonna see that this increases, hits this point right here. So what is this function? This is y equals ln x. So we're gonna keep this, and that's how we're gonna do everything else. So what the question is asking is that they give you a bunch of graphs, and they also give you a bunch of expressions. So let's start with this one. Y equals log x plus 1. And they ask you, identify which graph is which. Okay? So, basically, they'll give you the expression here, I, and then they'll give you the. Well, you already saw the book for question 11. They'll give you the graph. So maybe like for E's graph, right? They would give you that, and they would say, okay, are these the same? Which function belongs in which graph, right? They match them. So from here, what can you do? You can see that hey, the what is it? The transformation here is -1, 0, right? So what would this look like? Let's come back here. You can see that it's gonna what is it? It's gonna basically move here by -1, right? So now we have the intersection point here. We have -1 here. We're gonna start from here. We're gonna move here, right? So this is how that graph would look like. So I'll draw a mini version of the graph. This -1. But I'll draw this mini graph here. -1, 0. Should be here, right? So this is how that graph would look like. And this would correspond with graph E for the people who just want the answer. So write down this. So what the hell am I doing? Okay. So then from here I get from here. How do we say that? Okay. Next one. Y equals log x -1. This is the same thing. We're just gonna move this here, so it's gonna be like it's gonna start from here. And it's gonna intersect here. So x -1. So this is a transformation of 1, 0, and it'll look like this. So maybe this is 2, this is 1. It's going to start off here. It's going to move like that. Yeah. Then let's go for 3. Probably should write this down. A. This is the answer. For 3, we have y equals -ln x. Now we can see, hey, there's a reflection at the wall. Okay, not a reflection, I shouldn't say that. What's happening here is that y is decreasing, but x is staying the same. Like I said before, how does something like that look? It looks like this, right? So x is increasing here, but y is decreasing here. So it's like this, right? It's increasing, x is increasing, but then y is still decreasing. So it's gonna be like this. Right. So the graph would look like this. The answer is F. You wipe this board up. Okay, next one. We will start. So let's start with 4. 3 ln x, right? What's this? This is just a y stretch of this is just a y stretch of 3, and you can see there's a ln here, right? So there's one graph that you can see specifically in the question. So it's going to be a y stretch of 3. Right? Let's get back to it. So the graph would look like this. They give you the graph directly, so I don't really need to show you like the exact proof. And this is E. There's an E here because of ln x, so it would start from here. So this is the correct graph. For V, but this is V. For V, this would be y equals. Wow, my laptop is overheating. Okay, 2 minus x. Now, what's happening here? There is a reflection. No, sorry, I should stop using the word reflection because I don't understand that. Nothing is happening in the y-axis, right? Nothing's happening to the y scale, but there is something happening here, and that this is increasing, or decreasing, right? So what would this look like? This would look like this. This would y would be increasing, of course. So if y increases, it would go up. But then it would also. But then if x decreases, then it would go to the left. So how would I draw that? I would draw one here, so on, and I would draw two here. This is going to be a starting point. Then the reason why this is 2 is because, as you can see here, like we're going to set this as, okay, I should probably write this down. We're going to set this as 0. Okay, 2 minus x equals 0. So from here, 2 minus x equals 0. So then minus x is equal to minus 2. So x is equal to 2, right? So x is 2 here, right? We have 2 here. Then we're gonna move here. So this is how this would look, right? So you're gonna pick this one, which is this one is C. Okay, so C. Then the last one for the graph, the graph is y equals ln x plus 2. Now you should be able to do this by yourself, right? This is pretty easy. So this would just be set this as 0. So this would be a transformation of minus 2, 0. So if it starts off at 1, we'd go back 2. Right? So it would be here. Then we would go, and then we would start off 2. So minus 1, minus 2. Yep. And this would be this would be D, I think. Yeah, D. So this is the last for the graphical portion. It's very stupid, honestly. The way they explain it, at least in school. It's simple if you understand the ideas, right? But just a very bad explanation. Before I end this video off, I want to start with a little bit of question 12. So then later on during the algebra 2 portion of this chapter, it'll be a bit easier to explain. So, I can't believe I'm doing this on camera. Okay, so question 12. A. We have a2x equals e3. So in this question, it's given that L and A is equal to 3, right? This is given. So that means, hey, I want to find x here. So what can I do? Let's just do some manipulation with the logarithms, right? So if we ln both sides, if we find natural log of both sides, it'll be equal, right? So let's find ln of a2x, which is equal to ln e3, right? So what does this equal? We move this here, right? Just like we were taught. So 2x ln a is equal to ln. Move this here. So this would be 3l e, right? So what would this be? This would be 2 times 3 times 3 times. So this would be 2x times 3 because this is equal to 3. So 2x times 3 is equal to 3 times, this is 1. Right? So now we can do this. From here, we can just, divide 3 from both sides. So it's 3 by 3, which is equal to 1, right? Now let's keep 1. That means x is equal to 1 by 2. That's pretty simple. Next one's almost as easy. Pretty much the same thing. B. A3x equals E2. Now try doing this by yourself. You can probably do this how I showed you that one. So A3x is equal to ln E2. So this would be equal to 3x, and this would be times 3, because ln A is equal to 3. And this would be put here, we move this here, and then this is equal to 1, so 2. So then this equals to 9x is equal to 2. Therefore, x is equal to 2 by 9. It's the final form. This is the answer for this, right? The last one. No, I accidentally deleted that rule thing, but it doesn't matter. This is going to need some creativity, right? Now, we learned the substitution method in, or I'm not sure you guys did that in maths too, whatever. Okay, whatever. So we have this. I'm pretty sure you guys did it in maths too. Substitution method for solving quadratics. It's 2 equals 0. So this looks a bit messy. Let's say if I did okay, I don't like this, right? I don't like this because if I found ln of this, I wouldn't know the value because it's not ln of a, it's not ln of 3 of it. So I can't do that, right? So let's do something else. Let's take u, which is a substitution. Let's make this equal ax. So from there we can see that u squared, which is this, minus 3u, which is this, right? Plus 2 is equal to 0, right? Now we can just factor this. So you went to, you studied this, you know how to find the quadratic, but this is u minus 2, u plus 1 if you factor this, right? This looks like n. I am not doing sequences right now. U plus 1, that is e times 0. So this is equal to 0. Therefore, u1 is equal to 2. u2 is equal to, it should be negative 1. So, negative 1. u2 is equal to 1. Right? So now we can find, hey, u is equal to ax, right? So that means ax is equal to 2. Ax is equal to 1. Right? So from here we can find ln ax equals 2, ln of 2, right? So then this would, I should probably do this. Let's take this as I, and this is I. So of I, let's go here, ln ax is equal to ln 2. Right here, I'm doing the same thing, putting natural logs here. So then I move this here, and there's no x1 here, so I gotta move anything. So this would equal to is x is equal to ln a, right? So ln a is just 3. So this would be 3x. So 3x is equal to ln 2. So this is going to equal to x is equal to ln 2 over 3. So this is x1. And for x2, which is this case for I, it's going to equal to, if you prefer, I'm not going to do that. So ax is equal to 1. So then you're going to find the natural log of both sides and on the space. So like this, ax is equal to ln1. Now anything to the ln1 is equal to 0, right? Right. So then you do this, find the same thing because they're the same thing. So 3x equals 0. That means x is equal to 0. X2 is equal to 0. So the answers are these. Now this is the semi-algebraic, and then I did most of the graphical. So after this we'll be doing the word problems and stuff, which are much harder. Yep, that's about it.